Quadratic equations with complex solutions part 2. In this video, we'll look at how you can determine how many and what type of solutions there are for a given quadratic equation. The types of solutions are either rational, irrational, or complex. In the last video, Quadratic Equations with Complex Solutions Part 1, we looked at the definitions for each of those types of numbers. So what is a quadratic equation? It's an equation of the form ax squared plus bx plus c equals 0, where a, b, and c are real numbers and a is not equal to 0. So a quadratic equation can be solved using the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now the radicand of the quadratic formula is called the discriminant. That's b squared minus 4ac. So we can look at the discriminant, and if it's equal to 0, then there are two equal rational solutions. They're both the same, so we can say there's one solution. If the discriminant is greater than 0 and it's a perfect square, then there are two rational solutions. If the determinant is greater than 0 and it's not a perfect square, then there are two irrational solutions. And if the discriminant is less than 0, and then there are two complex solutions. So let's do some examples. Let's say we have x squared plus 3x minus 1 equals 0. X squared plus 3x minus 1 equals 0. Okay, so our quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a, and the discriminant is b squared minus 4ac. And remember, the form of the quadratic equation is ax squared plus bx plus c equals 0. So our a, b, and c in this equation is a equals 1, b equals 3, and c equals negative 1. So let's just plug those numbers into the discriminant. B squared minus 4ac equals b is 3. We square that, minus 4 times a, which is 1, times c, which is negative 1. So that equals 3 squared is 9. Negative 4 times 1 times negative 1 is positive 4, which equals 13. Okay, so the discriminant is greater than 0, and it's 13. So we go back here, we see number 2. It's greater than 0. Oh, I'm sorry, it's number 3. It's greater than 0, and it's not a perfect square. 13 is not a perfect square. Therefore, we know that there are two irrational solutions. There are two irrational solutions. Okay, that was our goal. That's what we were trying to find out with this particular problem. The number and the type of solutions. So let's do another one. Let's say we have x squared minus 5x plus 8 equals 0. Okay, here our a equals 1, our b equals negative 5, and our c equals 8. Our discriminant is b squared minus 4ac, so let's just plug these numbers into the discriminant. b is negative 5, so we have negative 5 squared minus 4 times a, which is 1, times c, which is 8. That equals negative 5 squared is 25. Negative 4 times 1 times 8 is negative 32. 25 minus 32 is negative 7. So our discriminant is negative. Therefore, we have two complex solutions. And again, that's what we were trying to find out. Just to go back, number 4 was if it's less than 0, then there are two complex solutions. So let's do one more example. Let's do 3x squared plus 2x minus 5 equal to 0. A equals 3, B equals 2, C equals negative 5, B squared minus 4AC is 2 squared minus 4 times 3 times negative 5. That equals 2 squared is 4. Negative 4 times 3 times negative 5. It's going to be positive. A negative times a positive times a negative is a positive. Let's see, 5 times 4 is 20. 20 times 3 is 60. So it equals 64. Okay, so it's greater than 0, and it is a perfect square, right? The square root of 64 is 8. So if it's greater than 0, and it's a perfect square, that's number 2. There are two rational solutions. So that's our final answer, 2 rational solutions. Okay, so in the next video, I will do some examples of solving quadratic equations with complex solutions.